Hello, everyone. I'm Olympia. Thank you for being here with me in this wonderful place called Lights Out Library. And I have a great story to tell you. Let's go back to space tonight with yet another space cruise to the outer limits of the solar system. Tonight we are exploring Pluto, the dwarf planet, its satellites, and the broader belt of bodies it belongs to, called the Kuiper Belt. And beyond it, a mysterious sphere, a swarm of distant objects around the solar system called the Oort Cloud. As usual, you will not need any particular knowledge of physics and space to follow our journey. But first, allow me to take a few seconds of your time to let you know that we have a Patreon page for those of you who wish to and can support this project, get more of it, and listen ad-free on your favorite podcast app. Patreon is a platform that allows you to contribute directly to our work financially. Our least expensive tier is $3.50 per month, but it doesn't mean you will get less. We let people contribute what they wish to or can, and everyone gets everything that is on our page. Because the world is a better place when the sun shines for everyone. If you join, you will gain access to various new features. For example, you will have the option to listen to all episodes with or without background sounds. You will have the capability to download all these episodes and participate in selecting future topics. We also offer advanced releases and updates on upcoming episodes. There are also many stories only available to our patrons. We have added links to Patreon, as well as links to different streaming options, which may be better suited for you. You will find these links in the description of the episode. But before we begin, allow yourself to forget about any worries. If you wish to, you may close your eyes and immerse yourself in the story. And if you do drift off, the story will be waiting for you. Now assume a comfortable position. Maybe move a bit to settle. Take a long, deep, relaxing breath. And when you slowly exhale, feel your shoulders drop. Release the tension in your neck. Let your face soften and your jaw relax. Make sure your fingers are not clenched and that your legs are relaxed too. And allow the sound of my voice to guide you through this journey. And now it's time to explore. Takeoff is impending. A well-known detail about our destination, Pluto, is that it lost its status as a planet 20 years ago, in 2006, when the International Astronomical Union redefined what constitutes a planet. This International Astronomical Union is an independent body that exists to advance astronomy in research and education. Its definitions and policies are relevant because all countries in the world with research capability in astronomy and space programs participate in it. The US and 70% of countries in North and South America, Europe, Russia, China, Japan, and India. So the rules that the International Astronomical Union produces matter and are typically accepted by astronomers and astrophysicists as conventions that facilitate research and cooperation. In 2006, the Union redefined planets, and Pluto was kicked out of the list of planets in the solar system because it no longer met the criteria. What are these criteria? There are three. A planet must orbit the Sun directly. That is to say, a satellite of another planet cannot be a planet, regardless of its size, because it doesn't have its own independent orbit around the Sun, as we will see in our space cruise. Pluto does orbit the Sun, so it qualifies as a planet on this first criterion. Criteria number 2. It must be spherical, or nearly so. This second condition disqualifies objects that are too small, because the ball shape that bodies adopt in space depends on their mass. When they are massive enough, the matter they are made of naturally adopts this shape due to gravitation. Matter gets distributed around a planetary core, generally very dense and hot due to the pressure of all the matter around it. This transformation into a ball requires a minimal mass, and again, Pluto passes this test successfully. It is big enough to form a ball. Where it fails is criteria number 3. The body must have cleared its orbit of debris. That is to say, it must have attracted and been absorbed by collisions or turned into satellites all other significant objects that populated the same orbit. This is not the case with Pluto, nor with another body like Ceres in the asteroid belt of the solar system. This region of the solar system between Mars and Jupiter has a higher density of small objects. Ceres is the biggest of them. It is spherical. It has its own orbit around the Sun, but it is part of an asteroid belt that it hasn't cleared. So it is a dwarf planet or a big asteroid too. Not a planet in its own right based on that definition. And this is why Pluto lost its planetary status 20 years ago, which mattered because the Astronomical Union makes the rules in that field. But this is just a problem of definitions. In the case of Pluto, this redefinition of what a planet was not random. It reflected a growing knowledge of what was beyond the 8th and now last planet of the solar system, beyond Neptune, another immense belt of bodies called the Kuiper Belt, of which Pluto is a part. Together with other bodies we will take a look at. Now we are leaving Earth and heading for Pluto. We will travel at more than light speed tonight because Pluto is far from us. The distance between Pluto and the Sun is 3.7 billion miles on average, 5.2 billion kilometers. I say on average because the orbit of Pluto is particularly elliptical. It is oval-shaped. At its closest, Pluto is less than 3 million miles from the Sun, and at its farthest, 4.6 billion miles, 50% farther. Maybe it is more telling to express these distances with light speed. It takes 8 minutes for the sunlight to reach the Earth. But for Pluto, it takes on average 5.5 hours. In other terms, Pluto is 40 times farther from the Sun than we are. So at light speed, it would take us hours to reach Pluto from the Earth. And this is why I say that by the power of imagination, we're going to travel faster than that and cross the orbits of Mars, then Jupiter, Saturn, Uranus, Neptune, and finally reach the Kuiper Belt and Pluto, a place from where the sun is just a bright but small point on the horizon, and barely any heat arrives from it. But if Pluto is small, actually smaller than the moon, and so far away from us, how was it discovered? It is invisible to the naked eye, like Neptune, which is closer and much bigger. So obviously Pluto is not going to be visible at all without powerful telescopes. The story of Pluto's discovery began in the early 20th century, driven by a quest to find a mysterious body, a mysterious planet X that was believed to affect the orbits of Neptune and Uranus. In the late 19th century, astronomers had noted small discrepancies in the orbits of these two planets. And from there, the hypothesis of another planet appeared, a planet that would cause these discrepancies due to its gravitation. One person that became particularly invested in that search was an American astronomer, Percival Lowell, who was wealthy enough to create his own observatory in Arizona. From there, starting in 1905, he started scanning the sky, looking for this hypothetical planet X. His intuition, based on flawed calculations, was that this planet would be rather big, 6 to 7 times Earth's mass, and that it would be located beyond Neptune. This second guess turned out to be correct, but despite all his efforts, the mysterious planet X he was looking for did not show up, and Lowell died in 1916 without finding it. But the search continued at Lowell Observatory, and 13 years later, in 1929, a young astronomer called Clyde Tombaugh noted that a faint dot had moved markedly between two photographic plates taken 6 days apart, indicating that it could not be a distant star, but had to be much closer to us. Further observations on this little dot confirmed that it orbited the Sun. Pluto had been spotted, and in 1930 its discovery was announced. A ninth planet of the solar system had been discovered. What puzzled astronomers, though, was that Pluto was much smaller than it should have been. To explain the observed discrepancies in the orbits of Neptune and Uranus, indeed, there was a mistake there. From the start, the hypothesis of a planet X, based on discrepancies in the orbits of Neptune and Uranus, had itself been based on a mistake. The measurements of Neptune's mass were inaccurate, and so the discrepancies observed were only for a small part due to Pluto's gravitation. The rest was a mistake. Still, despite its small size, Pluto was accepted as the ninth planet and remained unquestioned as a planet for about 60 years, until the 1990s. Because in the 90s, this region of the Kuiper Belt, a region of mostly icy bodies beyond Neptune, began to be discovered thanks to improved telescopes. It appeared that Pluto was not really a planet moving alone in space on its orbit, but rather the biggest, or one of the biggest, objects among many that formed this new, faraway asteroid belt called the Kuiper Belt. From there, the status of Pluto as a planet started to be questioned, ending with its reclassification in 2006. But we are now crossing the orbit of Neptune, the eighth planet, which is a bit more than 4 light hours away from the Sun. You remember, Pluto is on average 5.5 light hours away. So we are 80% there, and we can now start to decelerate as we enter the Kuiper Belt, the world Pluto is a part of. Let's take a look at it. So what is the Kuiper Belt exactly, and why does it exist? As I said before, the belt is made of small bodies, including dwarf planets. Pluto is the most famous, but we are going to take a look at others too. There are also comets and smaller icy bodies. Now don't imagine something crowded, because it really isn't. The belt spreads on a gigantic space, a kind of donut-shaped space that begins after Neptune and extends for almost the same distance as the Sun to Neptune distance, about 3 more light hours. So it is a very vast space, and in it there are millions of bodies, mostly small, but their total mass is at most 10% of Earth's mass, a tenth of our planet, maybe less, spread on such a gigantic expanse. This means that one could cross the Kuiper Belt without noticing it. It undeniably exists, but it is very empty and sparsely populated. In total, the number of objects of more than 100 kilometers in diameter, more than 60 miles in diameter, is estimated at 100,000. And there are millions of smaller ones. It sounds like a lot, but given the size of the belt, the average distances between them are still mind-boggling. And the vast majority of these isolated objects in the belt, some very small, are what is called icy bodies. Ice, in the astronomical sense, is the name given to different volatile compounds. Volatile meaning a substance that would easily evaporate, turn to gas at room temperature and pressure on Earth. Obviously, in space the conditions are very different, and they tend to be solid. It can be water ice, but not only. Methane, ammonia, nitrogen, carbon dioxide, these are astronomical ices too. including when they are part of ice giant planets like Uranus and Neptune. These ice giants are not blocks of solid water ice, contrary to what the name may suggest. Ice giants are like a subset of gas giants, like Jupiter or Saturn, except they contain more of these astronomical ices, which makes them significantly different. This is why Uranus and Neptune, the ice giants, are put in a different category than Jupiter and Saturn, the gas giants. Now, these ices, these frozen volatiles, can also be found on much smaller bodies, like the ones that populate the Kuiper Belt. And the tail of comets, too, is actually made of these ices. A comet, when it is far away from a star, looks like any other asteroid, but when it comes close enough to a star, the heat turns the frozen ices into gas, and this is what gives the comet a shiny tail. A tail that cannot be eternal, because every time a comet deploys its tail, it burns or loses some of its ice components. So it may take millions of years and thousands of orbits, but all comets end up exhausting their ices and losing their tails. In a minute, we will take a look at some remarkable objects of the Kuiper Belt, but we're going to explore different dwarf planets first. Pluto, and also Eris, Haumea, and Makemake. But first, how did the belt form? Why is it there, and what does it tell us about our solar system? The Kuiper Belt is widely believed to be a relic of the solar system's formation. And that is particularly interesting because it means it preserves material from the formation period that has undergone minimal heating or alteration since then, at least compared to bodies in the inner solar system that are closer to the Sun. So, in that sense, the belt would be a precious source of information about the early stages and the primordial matter of the solar system. Now, there's a scientific consensus about the age of the solar system, about 4.6 billion years, and the main principles of its formation, which is to say, from a disk of gas and dust, a solar nebula from which the Sun and the planets formed. But this consensus ends when it comes to how the Kuiper Belt formed, how it appeared. There are different theories. A first theory proposes that Kuiper Belt objects form roughly in situ, where they are today in the outer solar system, as part of the original material of the solar nebula. I told you about this standard model, this standard theory of the solar system's formation in previous episodes about space. It means that, like for other star systems, ours would be the product of the collapse on itself of a cloud of matter in suspension in space. Gas and dust that would have started to condense and rotate, possibly due to a shock wave in space created by the supernova of a distant star. This is believed to be the trigger to the formation of numerous star systems. So this disk, an accretion disk, because it would have rotated, its matter would have concentrated at the center. Most of its matter, actually, more than 99% of it, to form the star. And around it, on different orbits, planets would have ended up absorbing the matter available, clearing their orbits from other bodies or turning them into satellites. The models are more complex than that. They include matter traveling away from the center of the star and at other times coming back with bombardments of asteroids and planets. All of these details and their time frame are still debated. But that's the general idea. An accretion disk turning into a star and planets around it. So according to this first theory, the part of the solar nebula that extended beyond Neptune basically stayed where it was, with accretion turning dust into bigger bodies like dwarf planets and these many icy bodies, because the low temperature allowed volatiles to condense and form them. And since then, except for a few objects like comets that often originate in the Kuiper Belt, the belt would have remained broadly unchanged. A piece of evidence that supports the theory is that many Kuiper Belt bodies have circular orbits around the Sun, or nearly circular. Contrary to Pluto, which has a very elliptical orbit. We will see that later. And this suggests these circular objects that formed where they are today and were not significantly disturbed, because elliptical orbits tend to appear after disturbances when an object is expelled from a previous orbit or collides with something or is captured while it already has a high velocity. And it doesn't seem to be the case here for the vast majority of objects in the Kuiper Belt, which is why the theory that most of it formed where it is now makes sense. Another piece of evidence is that the elements present in the belt, especially a lot of the methane and less water ice than in the inner solar system, align with models of the solar nebula before the formation of the system. So the elements the Kuiper Belt is made of would have already been in the same location billions of years ago. So that sounds like a strong theory, but it has two problems. The first one is that the density of material in the belt is very low, as we have seen before. Actually so low that it becomes difficult, if not impossible, to explain how dwarf planets like Pluto would have formed there. If the belt had been stable for so long, there would just not have been enough matter density and movement to create these larger bodies. Now, maybe most of the belt is ancient indeed, and dwarf planets like Pluto would have arrived later. That's possible. But another problem with the theory that the belt formed where it is on the outskirts of the solar nebula is that the belt ends abruptly. After a distance that is equivalent to about the Sun-Neptune distance, the belt disappears. Its density was already low, as we saw, but it drops to almost nothing. Now, this is a problem because logically, if the belt was born only from a bit of accretion at the periphery of the solar nebula, its density should decrease progressively as one travels away from the sun, not end abruptly with a clear-cut edge. This again does not completely disprove the first theory, but it suggests at least external influences that this first theory does not account for. So this first theory is not fully satisfactory, but there are other possible explanations for the formation of the belt. The second one is that all planets of the solar system and the bodies of the Kuiper Belt formed closer to the Sun in a range of 10 to 20 astronomical units. One astronomical unit is equivalent to the Sun-Earth distance. So 10 to 20 astronomical units is 10 to 20 times the distance. Bearing in mind that today Neptune is at 30 units and the Kuiper Belt begins at 30 units and extends to approximately 50 astronomical units. So, in this other model of the formation of the solar system, called the dynamical scattering model, the four giant planets of the solar system, Jupiter, Saturn, Uranus, and Neptune, would have appeared on closer orbits than they are now, and later gravitational interactions described this model would have made them migrate outward. Neptune, in particular, would have migrated from 20 to 30 astronomical units, its current position. And as Neptune migrated, it would have scattered plenty of planetesimals and small bodies outward, thus creating the Kuiper Belt. That sounds like a huge influence for Neptune. But remember that the total mass of the belt is not that big. At most 1/10 of the Earth's mass. That's not much in comparison with Neptune alone. This dynamical scattering model has the big advantage of also explaining the resonance of objects like Pluto with Neptune. That is to say that their orbits seem to be synchronized. For example, every time Neptune completes 3 orbits around the Sun, Pluto completes 2. This ratio of 3 to 2 is locked, and other bodies of the Kuiper Belt have the same type of resonance as Neptune. So this model describes a much more eventful and chaotic creation of the Kuiper Belt, and that's a strength, because it explains some of the dynamics observed in the belt, such as very elliptical orbits, or these orbital resonances with Neptune that the first theory fails to describe. It would also explain why other planets, like Jupiter, have what is called Trojan asteroids, meaning asteroids on the same orbit that remain always at the same distance from the planet after or before it on the orbit. This model provides an example of the appearance of this phenomenon, as the planets would have migrated away from their original orbits. So that's also a seducing theory. But when it comes to the Kuiper Belt, it fails to explain these icy bodies with circular orbits that seem to have appeared where they are now and have been undisturbed for so long. It also leaves questions unanswered about when this planet migration took place and what caused it. So again, a theory that could bring a partial explanation to the question of how the Kuiper Belt formed but that is not fully satisfactory at this point. And some of the missing points could be in yet other theories that are not so much about the initial formation of the belt, but the possible external perturbations that would have given it its current characteristics. External perturbations could explain the limitations of the first two theories, the presence of elliptical orbits and big bodies, despite the formation of the belt in its current location, as in the first theory, or the presence of icy bodies that don't seem to have formed anywhere else for the second one. So, some other theories propose that the Kuiper Belt would have been influenced by external events, external factors, such as a close stellar encounter, meaning another star passing close enough to the solar system to visibly disturb it, or an undiscovered planet maybe in or beyond the belt. In particular, I told you that a challenge to theory number one was that the belt band ended abruptly at about 50 astronomical units. The density drops, it ends, instead of progressively fading. And that could be due to the passing of a star that would have truncated the belt, attracted everything of importance that was beyond the 50 astronomical units, and so created that edge. This is very hard to prove or disprove. It would have happened billions of years ago, and it is possible. But stellar encounters are very rare in our galaxy. Stars typically orbit the galactic center and stay at a distance from each other, so it is likely to remain hypothetical. Another type of perturbation could be caused by a planet, an undiscovered planet that is sometimes called Planet 9. Planet 9 used to be Pluto, but now that Pluto is no longer a planet, Planet 9 is undiscovered, if it exists. This Planet 9 hypothesis was proposed recently, in 2016, based on the observed orbits of objects in the Kuiper Belt, orbits that could be influenced by another body far beyond Neptune. And indeed, the proposed characteristics of Planet 9 place it very, very far on a highly elliptical orbit that would see its distance to the Sun vary from 400 to 700 astronomical units. For comparison, I told you that the Earth is at 1 astronomical unit from the Sun. That's the definition of the unit. And you remember Neptune is at 30 astronomical units. The Kuiper Belt ends at around 50. And now we're talking about a planet orbiting at more than 400 astronomical units. Something like at least 13 times farther than Neptune is from the Sun. This Planet 9 would have 5 to 10 Earth masses that would likely be a gas or ice giant. Given the distance, it would take it 10,000 to 20,000 years to orbit the Sun. The elements of evidence or clues that support this Planet 9 hypothesis are that several bodies in the Kuiper Belt have aligned objects that could be influenced by a single massive body. Some have orbits that are tilted or inclined, compared with the plane of the solar system. and this also suggests an external influence. Now, to many scientists, that is not enough to prove anything because the aligned orbits could be due to observational bias. There are tens of thousands of bodies of more than 100 kilometers in diameter within the belt. So, statistically, some are going to have comparable orbits. Or the similarities could be due to the gravitational influence of other bodies in the Kuiper Belt. So, this is still debated. But the existence of a mystery planet 9 cannot be fully ruled out. After all, Planet 8, Neptune, was discovered late in the 19th century and entirely without seeing it. It was discovered due to its gravitational influence. But maybe it was not the last planet of the solar system. If another planet exists so far away that we had not been able to see it yet. Now, let's finally approach Pluto and see what we have. I told you it was smaller than the Moon. Actually, it has about 2/3 of the Moon's diameter. The duration of the Plutonian year, the time to complete one revolution around the Sun, is 248 of our years. The surface was mapped in 2015 by a probe, New Horizons, which revealed the diverse geography it has: icy plains, mountains, craters, and a surface that shows evidence of geological activity, of possibly volcanism or ice flows, because the surface doesn't look that old. Billion years old impact craters have disappeared, and this means surface material must have been renewed somehow. This is one way of estimating the geological activity of planets and satellites in the solar system. The planet's composition includes a mix of ices, rocks, and organic compounds. It is believed that the inside consists of a rocky core, a mix of metal and rock, of silicates, that would account for about 2/3 of its mass. Around the core, there would be a mantle of ice, mainly water ices, possibly with a liquid part beneath the surface. A notion of liquid water, or a mix of water and ammonia that could remain liquid because it would be taken between the hot core and the very cold crust of the planet, probably several miles thick, of hard ice. The surface is really very cold, and given the distance to the Sun and the absence of a significant atmosphere, the temperature is rather stable around Pluto. On average, the temperature is around minus 380 degrees Fahrenheit or minus 229 degrees Celsius. That's only about 40 degrees above absolute zero. The Sun is so far away that it doesn't make much difference whether you are near the poles or the equator. But the atmosphere actually changes a bit, depending on where Pluto is on its elliptical orbit. When it is at its farthest, temperature falls to minus 400 degrees, and there would not be any significant atmosphere when it all happens. But when it is a bit closer to the Sun, the slight rise in temperature to negative 360 Fahrenheit makes some of the ices at the surface sublimate. That is to say, they turn into gas and form a temporary atmosphere that gets quickly lost because the small mass of Pluto does not retain it. So as soon as the temperature decreases again, these volatiles are lost or return to solid state, fall on the surface, and Pluto loses its thin atmosphere again. This cycle would repeat with each revolution of 248 years. I mentioned that there could be an ocean, a subsurface ocean under the thick ice layer. Like many bodies in the solar system, starting from the asteroid belt and including different satellites, it is believed to maybe have such a dark ocean with a relatively hot floor. The heat from the core in such a planet or dwarf planet comes from two things. There is residual heat that remained trapped there from its formation because the formation happened with collisions. And there is also radioactive decay. We know that this is a factor that contributes to the heat inside our planet. As you probably already know, it is speculated that on some bodies of the solar system, these subsurface oceans could maybe harbor forms of life, maybe rather basic life, but life made possible by a liquid medium, energy heat from the hot core, and chemicals dissolved in the water. We have no signs at this point that this potential for life has led to the actual appearance of life forms. And other bodies, such as Europa, for example, a satellite of Jupiter, are seen as more likely to harbor it. But it is not completely impossible that in the depths of Pluto's subsurface ocean, if it exists, life chemistry could be at play. Now, what is easier to investigate is the surface. On the surface, we have different kinds of ices. There is nitrogen ice, methane ice, which is found across the surface, water ice, which is believed to be what the mountains on Pluto are made of, and in smaller quantities, carbon monoxide ice. Now, there are parts, regions of the surface where Pluto looks reddish, and this red color comes from compounds that are called tholins, Tholins. They are often found on cold bodies with high ice component, such as Triton, a moon of Neptune. Tholins are big, complex organic compounds that appear when molecules containing methane or ammonia or nitrogen are irradiated, especially by UV light or cosmic rays, such as the one the sun sends us. Tholins are not a precise type of molecule, and we don't need to go into the chemical details of them. But these compounds have a reddish-brown hue that could make them look like rock from afar, but they are not. Tholins matter because they are a prime example of organic chemistry in space. Their presence on Pluto or Triton or on other bodies, including asteroids, illustrates that chemical processes triggered by sunlight or rays happen in very cold and distant environments and can travel through space. This could be a mechanism for the appearance of not life itself. Organic compounds are not life, but they are bricks, constituents, or necessary steps for the appearance of organic life forms. Tholins traveling in space, arriving on planets like ours. This could be a mechanism that helped life emerge from simpler molecules. In any case, tholins are what gives regions of Pluto their reddish color. But not all is ice and tholins at the surface. There is also dust mixed with other elements, forming a layer of material called regolith. Regolith from Greek literally means blanket of rock. It is a fragmented layer of material, a mix of dust, soil, broken rock, and other fine particles, including ices. A layer that covers the surface of many rocky bodies. The Moon, Mars, asteroids, and also Pluto are covered in regolith. So the composition varies, and the regolith on the surface of rocky bodies forms from different things. It can come from meteorite impacts. When a meteorite crashes on a rocky surface, it creates fine dust and debris. A big part of the regolith on the surface of the Moon, for example, resulted from impacts. Regolith can also appear on bodies that are exposed to extreme day and night cycles with bigger changes in temperature. This can fragment, break rock, and turn it into pebbles or dust. Another source of regolith is volcanic or cryovolcanic activity. Cryovolcanic, that is to say, cooled volcanoes that do not eject lava but ices. Cryovolcanism on Pluto probably contributed to depositing icy regolith at the surface. And finally, as this dust and fragments are on bodies without an atmosphere, or with a very thin one exposed to solar wind and cosmic rays, they get chemically modified with time, like for the tholins I discussed before. And these are the reasons why Mars, the Moon, other satellites in the solar system, or Pluto, end up covered in this material that can range from powdery dust to gravel-like fragments, depending on the body and its history. One of the many elements that were discovered, thanks to the New Horizons mission, is that the regolith on Pluto is dynamic. It is not just a layer that has accumulated over time, like on the Moon, but instead it changes constantly due to sublimation, transformation into gas of its icy, volatile components when Pluto gets closer to the Sun, as we saw before, or due to cryovolcanism. So even though Pluto is plunged in the dark, very far from other planets, and unlikely to harbor life with its extreme cold, it is not completely inactive. Things constantly happen on its surface. Pluto might be way smaller than Earth and smaller than the Moon, but it has more natural satellites. 5 are known, and only the largest, Charon, was discovered by ground-based telescopes. The 4 others were spotted by the Hubble telescope since 2005. Charon is proportionally large for a satellite. It has half the diameter of Pluto and 12% of its mass, which is enough for their common center of mass to be outside Pluto. So technically, Charon is a satellite of Pluto because it is smaller, but both bodies orbit around their center of mass, their common center of mass, and sometimes they are considered together as a binary system, like a double planet, or a double dwarf planet in this case. Charon was discovered in 1978, and it is tidally locked to Pluto, which means the same sides of Pluto and Charon always face each other, like for the Earth and the Moon. Charon's composition would be broadly similar to Pluto's, but probably without a subsurface ocean. The other satellites are similar, but not massive enough to be turned into balls by hydrostatic equilibrium. This mechanism I told you about before at the beginning, the mechanism that makes larger bodies adopt a spherical shape. So the 4 other satellites are irregular, and they were invisible from Earth. They were discovered after 2005 by teams working with the Hubble telescope. They have been named Styx, Nix, Kerberos, and Hydra. Their composition is thought to be dominated by water ice too. We saw that Pluto's orbit was elliptical, but also tilted, meaning that it is not aligned with the plane of the solar system. And this raises another question. When you look at representations of the solar system, planets are all located on a two-dimensional plane, like a flat space that makes the solar system look like a disk rather than a sphere. And the same type of plane of arrangement seems to be true for other systems observed, or even for galaxies. All these systems look like disks. They are much wider than thicker. This planar arrangement is not perfect, though. Planets can typically have orbits that slightly deviate from the plane. The plane, also called the ecliptic in the solar system, and sometimes they deviate more. Comets often deviate quite a lot, and so does Pluto, that deviates about 17 degrees. But why is that? Why do star systems and galaxies arrange on planes instead of being like spheres, for example? It has to do with the laws of physics for a part and their formation process for the rest. In physics, there is this concept of angular momentum, which we could define as the tendency of an object to resist change in its rotational motion. Once an object has started to spin or to rotate, it resists a change in that rotation. And one characteristic of angular momentum is that it is a conserved quantity. As long as no external intervention stops it, it remains constant. That sounds a bit theoretical. So let's take a look at a concrete example. Let's take a look at our planet. The Earth has, at the same time, orbital angular momentum. Due to its movement around the Sun and spin angular momentum, it rotates on its axis. The Earth does both things without an external intervention that makes it orbit the Sun or spin. It does it because it acquired this orbital and spin angular momentum billions of years ago. And since nothing has stopped it since then, there is no friction with air and space. It happens in the void, so it continues. Conservation of the angular momentum also means that if for some reason the Earth suddenly shrank, it would also start to spin faster. Like when a figure skater pulls their arms during a spin that makes them suddenly accelerate their spin faster. Not because they are putting more effort in it. It happens automatically because the decrease in their diameter, as has this spin when they pull their arms. In physics term, the decrease in their momentum of inertia needs to be compensated by a higher speed, a higher angular velocity, so that overall their angular momentum, the product of the two, remains the same. In the case we are looking at right now, the angular momentum means that once a body has started orbiting on a given plane around the star, it will not change easily. It takes a major external event or influence to make it change plane. Not impossible. We have the example of Pluto, but uncommon. A massive object, like a big planet, is unlikely to deviate much from its original orbital plane. Now, this plane comes from the initial formation process of the star system. As we saw at the beginning, a new system starts as a disk because when a large quantity of matter collapses on itself in a corner of the universe, when it starts to spin, it will naturally adopt the disk shape. The rotation expands outward and flattens it due to the centrifugal force. Now, all star systems do not have parallel planes. There is no up or down in space. Their plane will depend on the circumstances of their formation. But observation of other star systems indicates that the same phenomenon repeats itself. And galaxies too. They tend to have this disk shape, large and flat, because they also spin around the galactic center, a gigantic black hole that keeps the galaxy together with its gravitational force. And this is why planets, moons, asteroids in the solar system, all bodies that formed within it from material from the protoplanetary disk, this primordial accretion disk inherited its planar orientation. After millions or billions of revolutions around the Sun, planets are still on this plane today, with very slight deviations which, when they exist, were caused by their history, bombardment by asteroids, collisions, and possibly the influence of external bodies, but they typically don't deviate much. Massive planets like Jupiter and Saturn actually shepherd smaller bodies via their gravitational influence. They force these smaller bodies to stay in the elliptic plane, reducing any attempt at deviating from it. Over time, another phenomenon that reinforces the planar arrangement is that orbits in a plane are energetically favorable. A body that orbits far from the ecliptic experiences greater gravitational perturbations from other bodies, from other planets of the system. So it takes more energy to maintain this path out of the main plane. Over time, between collisions, a little bit of drag, of friction, from the residual gas in space and gravitational influences from planets, all of this tends to reduce the tilt, the inclination of an orbit. It makes the body align more with the system's plane. So, these are the physical constraints and principles. But there are bodies like Pluto with a significant inclination in their orbit, meaning that they travel in space successively above and below the elliptic plane. As I mentioned, it is a 17-degree inclination for Pluto relative to the solar system's plane. This tilt, this inclination, must be due to external influences, and Pluto is actually not alone in that case in the Kuiper Belt. Comets that originate from it also often have these highly inclined orbits. In the case of Pluto, this is probably a consequence of past collisions or major external perturbations, probably due to Neptune. The interactions between the two could have tilted the orbit. Neptune is a suspect, but not the only one. We are back to the hypothesis I mentioned before about the formation and characteristics of the Kuiper Belt. It could also be a past stellar encounter, or why not, this elusive Planet 9 that caused it. Pluto is not the only dwarf planet in the belt. There are a few others that were discovered in the 2000s. For example, Haumea, named after the Hawaiian goddess of childbirth. Haumea rotates very fast on its axis, which gives it a slightly oblate shape. Its surface is dominated by water ice, rather pure water ice, judging by its high reflection of sunlight, its high albedo, as it is called. Under this icy surface, it probably has a rocky core, and Haumea probably had a violent history of collision to acquire such a fast spin. Its rotation, its day, takes less than 4 hours. It is the fastest known rotation of any large solar system body. Another dwarf planet is Makemake, named after the god of creation of the Rapa Nui, the people from Easter Island. Makemake is also spherical. It is smaller than Pluto and orbits farther. It takes 310 years to complete one revolution, while it takes 248 years for Pluto. Composition-wise, Makemake is a close analog to Pluto. Yet another important body is Eris, named after the Greek goddess of discord. Eris is slightly smaller than Pluto, but more massive, and on average, it orbits further, needing 558 years to complete its orbit. Its orbit is even more tilted, even more inclined than Pluto's. At 44 degrees of inclination to the ecliptic versus, you remember, 17 degrees for Pluto. None of these bodies are really big compared with planets and main satellites of the solar system. And I could list more of them, even though their precise composition and history remain uncertain. But they are all parts of the Kuiper Belt and remind us that the solar system doesn't end with the planets. There is another world beyond Neptune. But what is there beyond the Kuiper Belt itself? Is it the void of interstellar space already? Or is there something else? Maybe there is something else. Something called the Oort Cloud. It is named after the Dutch astronomer Jan Oort, who proposed it as the birthplace of long-period comets in the solar system. Short-period comets, the ones that come back more often, are believed to have originated in the Kuiper Belt. But longer-period ones, such as the Hale-Bopp comet that takes 200 years to orbit, would have to come from farther, hence this hypothetical cloud of objects. It could have formed early in the formation of the solar system, 4.6 billion years ago, when leftover gas and dust from the protoplanetary disk would have been flung outward by gas giants Jupiter and Saturn, and possibly other influences like stars or other undiscovered planets like Planet 9. Due to the extreme distance from the Sun and the multiplicity of influences, including from bodies that were not on the elliptic plane of the solar system, this matter would not have spread on a disk like the Kuiper Belt, but instead adopted chaotic orbits, forming a cloud like a giant sphere, a bubble enveloping the solar system at a huge distance. Here again, the orders of magnitude are mind-boggling. I told you earlier, the Earth is at 1 astronomical unit from the Sun. Neptune is at 30 astronomical units. The Kuiper Belt stretches from 30 to 50 or 60 astronomical units. The Oort Cloud, the spherical bubble around the solar system, would be between 2,000 to 100,000 astronomical units. The distances are on another order of magnitude. That's up to 1.5 light years away, nearly halfway to the nearest star, Proxima Centauri. So the cloud could be gigantic, but not dense at all. The trillions of small and medium-sized bodies that would belong to the cloud would have combined mass of only 5 to 10 times the Earth. Scattered on such a vast expanse, it really is not much, and the cloud would be very faint. I speak of it in the conditional because it is not proven either. It is so far, its objects are so faint, that we never see them, so we cannot be sure it exists. Its existence is a hypothesis created or inferred from the existence of certain comets and their paths, combined with the formation models of the solar system that indicate its existence is possible. Not necessarily likely, but possible. No spacecraft, not even New Horizons that visited Pluto, has gone that far. And so, for the moment, this distant, icy frontier remains full of secrets about our solar system's present and past. We have reached the end of our exploration journey for tonight. You can now let go and fall asleep. Or if you're not sleepy yet, you may pick another story from my ever growing library. And until we meet again, good night. Sleep well.